All right, ladies and gentlemen, let's check our answers here. Number 1, what are the coefficients? Raise your hand. Coefficients number 1. Yes, right here. Say what the coefficients would be. Yep, what goes here? No, just the numbers, nothing there. All right, 1, yep.
3.
Yep.
And 2.
Yep, that's right. Number 2. Yep.
First one is 2 and the second one is nothing.
Okay. And what about down here?
Down there is nothing and then nothing and then nothing.
Very good. Nothing indicates a 1. Very good. But it's nothing written. Very good. Number 3. What's right here? First chemical is a what? 2. Very good. Second one is a what? 7. Then a what? Then a what? And the last one. Can I get this to work? There we go. So last one is 3261. 3261. They are purple, that's right. We got our red back, so good news. All right, now, in chemical equations, we want to take the words and translate them into something that is decipherable. So, when you have and, with, mix, or dissolve, that is the positive sign. You're adding things together. And, with, mixed, or dissolved. The arrow means produced, decomposed, combust, burn, electrolyzed, or formed. Sometimes it's also referred to as yields. The S means precipitate, suspension, turnings, pellet, or ribbon. The L means molten. If you ever see the word molten, it's referring to a liquid. Okay? There's not a lot of pure liquids at standard state besides mercury and water. Solution or acid. AQ means solution or acid. Now, if we have a English written out explanation of a chemical equation, we are going to now write and balance equations for these reactions. So on the first one, we've got lead 2 nitrate. Let's do the first one together. So lead 2, what is the charge on lead 2 and the symbol for lead 2? All right, it's Pb. What's its charge? The Roman numeral is 2, so it's going to be what? 2 plus. And it's nitrate. Nitrate's formula is NO3, and it's a 1 minus. So we have to make the formula correct. So we need 2 nitrates for every 1 lead 2. It reacts with, what symbol do we write for reacts with? Plus. Reacts with is plus. Potassium chromate. Potassium is K. Chromate. CrO4. What's the charge on chromate? 2 minus. And potassium? 1 plus. So just write a plus there. Don't usually write the 1s because then it looks like a positive sign when it should be negative. 2-form. 2-form represented by the arrow. Lead 2 chromate. I already know my lead 2. Yes? Oh, potassium chromate. That's right. You haven't written the correct formula for it? Good job. That's a good time to do it. How many Ks do we need? 2 Ks. All right. Excellent. So don't skip ahead until you write the correct formulas. That's totally cool. Or you can do it all at once. It's your choice. Pb plus 2. And chromate is CrO4 2 minus. That's good to go. And potassium nitrate is going to be KNO3. We got a plus here and a minus here, which means we don't have to do anything to its formula. It's good to go. Okay. Now, we have all the formulas done. After we write the formulas, what do we have to do now? Right. Balance it out. Now, a trick you can do which I really like, but you can choose to do whatever you'd like because this is your class. This here is the NO3, that's the nitrate. This here, that's the nitrate. If you count the entire nitrate together, instead of individually atoms, it goes faster sometimes. In this case, it doesn't look like the nitrate or the chromate are changing. So all I have to do is count up how many I have on either side. So, when you balance it, you might be able to quickly see, on this side I've got 1 lead. On the right side I've got 1 lead. The lead looks good. On the left side I got 2 nitrates. There's my 2. On the right side I got how many nitrates? 1. So I'm going to put a 2 in front of this. 2 in front of potassium nitrate. Now we got 2 potassiums on the right side, and how many potassiums on the left? 2. 1 chromate on the left, 1 chromate on the right. That's all you had to do to balance that particular equation. So, it is a trick that sometimes helps, especially if you see it's the species stay together. These things, ions, are called species. Kind of a unique name, but the species stay together. You can use that trick to help you out. If you count individual atoms, you won't be wrong. It just might take you like a little bit longer. Okay? So, I'd like you to write and balance these 3 equations right now using your ion sheet, periodic table, and your notes. Ready, set, go. Your oxygen gas, nitrogen gas, chlorine gas, bromine gas, iodine salt. NH3 is also, it's called ammonia. We call it nitrogen trihydrate. That way, so water, ammonia, and methane. Common thing we have to be aware of. Those common names, on the AP test way often they will have to go through. Yeah, some people inspection just comes for them. Other people want algebra and real easy algebra, easy math. All right, ladies and gentlemen, let's look at these two. Okay, I want to check in with you. I also want to show you another way of solving equations if inspection is not your friend. So, first one, looking up here. This is the balanced equation for lead nitrate reacting with potassium chromate, forming lead 2 chromate and potassium nitrate. The second one, zinc metal. Zinc metal here is zinc by itself. It does not have a charge. When it says it's just a pure metal, it will not have a charge. It only has a charge when it's in an ionic compound or as an ion. So this is the equation for number 2. Thumbs up for ready to go on. Number 3. All right. Number 3. Yes. Go over number 4. I'd love to. Now, number 4, is it the balancing or the writing that's a challenge? Balancing, okay. So, number 4, I will go through number 4, how to balance it. I am going to show you 2 ways. 2 ways. So, you have complete choice. I'll show you inspection, and then I'll show you another technique, which sometimes people love. So, if you're really good at inspection, don't even worry about the second technique. I only use the second technique when I have been spending more than 5 minutes on a problem. So if you get to that point tonight, maybe you want to think about using the second technique. So how to solve this? Let's get it written down. If I can change pages, there we go. So NH3. So we've got our NH3. We're adding to that our oxygen. And this is producing our nitrogen monoxide and our water. Ammonia. Ammonia is one of the few chemicals that has a specific name. Ammonia is NH3.
It's not on the list.
No, it's not on the list. It's not an ion. Ammonia. CH4 is methane. And the one that everyone remembers, H2O, is water. These are names that are convention names that are remembered based on the molecular structure. These are covalent molecules that have conventional names, kind of like benzene as well. So, there is an ion that sounds like ammonia. That one here is ammonium, NH4 plus. So that's another way you can remember it. If you memorize ammonium, you can know ammonia just doesn't have that positive charge and that hydrogen on it. Now to balance NH3 plus O2, making NO plus H2O. Okay, one technique, of course, is our inspection. So we have one nitrogen on the left, 3 hydrogens on the left, 2 oxygens. We go over to the right, 1 nitrogen, 1 oxygen. Then we have 2 hydrogens and 1 more oxygen here. I separated out my oxygens so I don't get confused as I'm counting. So the next thing is, our oxygens and hydrogens are not balanced, or nitrogens seem to be. So I know the coefficient for each N is going to be the same. So if I look at my H's, I've got 2 here and 3 there. To guess really quickly, if I put a 3 here, just as a guess, I got 6 here and 3 O's here. Over here I've got 3 H's. I've got to double that to get 2 H's here. I mean 2 times 3, 6 H's and 2 N's. But now we've got a problem. The N's are no longer equal. Multiply that by 2, I get a 2 and I get a 2. Now you can already see that this is a problem because as you change the N's, it changes the H's, and the N's and H's are connected. So my H's are equal. Yay, H's. But my O's are not. I've got 5 on this side and 2 on this side. So what I do is I multiply this here by 5 halves. 5 halves here. So you multiply that by 5 halves. Now I've got a total of 5 oxygens on this side. And if I counted right, I've got 5 on this side, 6 H's and 2 N's. Then we have to multiply the whole thing by 2 because the 5 halves has to go away. So you multiply the whole equation by 2, that gives you a 4, gives you a 5, gives you a 4, and gives you a 6. So that is how one way of solving that problem. Okay? One way. Now, I want to show you another way that is almost as fast, and for some people will be easier. I only use this when I get on really tough ones. So I usually use inspection first. If it takes me longer than a minute to inspect it, I'll use this technique. Okay? Now again, the same equation we have. We have our NH3 plus our O2, making NO plus water. Is that right?
Yeah.
Just trying to do it by memory. There we go. Now what we do is we want to find out the coefficients. So we're going to use symbols, A, B, C, and D. These are random letters chosen because I'm going to use simple algebra, very easy algebra. So the first one, N. I've got A N's in the first one, none in the second. In the third one, I know that the N's on the left have to equal the N's on the right. I've got C N's on the right. Then I go to the next element, hydrogen. Got 3 A's worth of hydrogen. 3 times A, none in B, none in C, and 2 times D in the water. Then I look at my last element, which is oxygen. 2 times B. There's none in the first NH3, then C, and then there's D. There's an oxygen in each of those. Now, once you have these 3 equations set up, all you have to do is make an assumption. Okay? You assume that A equals 1. So, A equals 1. If A equals 1, then C equals 1. So my first coefficient over here I'm going to put as a 1. This is a 1 as well, based on my math. Then if A equals 1, 3 times 1 equals 2D. Doing some simple algebra, 3, 2, 3 halves equals D. There's my D, it's 3 halves. Then the last one, I've got to find out what B is. 2B equals C plus D. C is currently 1, D is 3 halves. Makes it too hard. What is that, 5 halves? 5 halves equals 2B. And then B equals 5/4. So that's our coefficients. The problem with the coefficients is they are not whole numbers, so you multiply the whole thing by 4. So that's going to be 4, that's going to be 5, that's going to be 4, and then 4 times this is going to be 6. Cha-ching, you got it right, you're good to go. So, tomorrow, ion quiz. This is a sample ion quiz of what you can expect. Something like this for tomorrow. Tomorrow we will be doing the chalk lab, and for homework, the balancing chemical equations. Ion quiz here. If you'd like to check in before you leave with what the answers should be, you're welcome to do that. We will see you guys tomorrow.
Yeah.